Reconstruct Itinerary, and the key idea is to treat the tickets as a directed graph and then use DFS to find an Eulerian path. Now the itinerary must start at JFK and we use every ticket exactly once, and it must be the smallest. Now I've already written the code and we are using the classic DFS approach. So you start with initializing a graph, then you explore tickets and we build a graph. So we put the source and the destination in the graph. So where is it starting from? Where is it going to? We reverse it because when we pop, we want to get the smallest one. We have a result empty array. Then we start our DFS, which takes in the airport. Now we explore this airport, which is in our graph, and we explore it until it's empty, until the graph still has airports. And then we pop from the graph and we assign it to be the next airport, and then we explore DFS on this next airport. After we are done with this whole exploration phase is when we append this airport to our result. We then call DFS on JFK and we reverse our result at the end because we are over here reversing it to begin with. So I will start with an example. So for instance, we have this example, JFK to KUL, KUL to SFO, yada yada yada. We want our path to be JFK, KUL, SFO, Atlanta, JFK, SFO. So we start by building a graph. So we build a graph, where is JFK going? It's going to KUL and SFO. We add it. We do it for every single airport. We build our graph. And then, as the code says, we sort the destinations in reverse order. So when we sort it in reverse order, JFK, KUL, SFO becomes SFO, KUL. Now, why are we reversing it? Because we are popping it over here. So popping always removes the last element. So we want to make sure that we remove KUL first because JFK visits KUL first. Hence, we are gonna reverse it because that will be the smallest destination. Then we start our DFS from JFK. Now JFK takes KUL. So then we explore the next airport, which is KUL over here. Then KUL goes to SFO. So then we explore the next airport, SFO. And then SFO goes to Atlanta. So we do DFS on Atlanta then. And then Atlanta then goes to JFK. So then we go to JFK again. And then we go to SFO because JFK still has its path. So one ticket left to SFO. Then we go to SFO. And then we go to SFO. SFO has nothing. It has no tickets left because we have already explored Atlanta. So that's when this line runs, result.append airport. And which airport will we append? The airport that we were exploring at this time, which was SFO. So then we will append SFO into result, like over here. So now result becomes SFO. And then we return to the previous DFS call, which was JFK. So before SFO, we were at JFK. Now JFK now has no tickets left. We have explored SFO, we have explored KUL. In fact, JFK was this because we reversed it. So we have explored KUL first and then we explored SFO. So now we can append JFK. So this, because this line will run again, then we append JFK. So this becomes a result. Then we go back to the call which was before JFK. So which call was before JFK? It was Atlanta. So then we explore Atlanta and we see where there's no tickets left. We have already explored JFK, so we add Atlanta. Similarly, then we explore, we go back further, we see SFO, we have completely used all our tickets, we add SFO to the result, then we add KUL, and then at the end we add JFK again, because when we explored KUL, we go back to JFK, we have already explored JFK, so we add JFK, and this is our result. And then you return result, you reverse it, so then our result becomes this, the highlighted version. Now bear in mind that we are not appending immediately, that we are not appending and then doing DFS on the next airport. And the reason for that is that sometimes we need to revisit another airport. So an example was this. First we revisited KUL, then we came back and revisited SFO. So we need to visit another airport. So we come back to the current airport before the itinerary is complete. So we keep our tickets until we get stuck, and then we add the airport to the answer. And yeah, this is the final answer.